Hello, this is Matthew from Simplilearn, and today we're going to dig through what Docker is and how you could be using it within your own DevOps environment. So let's get started. In this presentation, we're going to go through a number of key things. We're going to compare Docker versus traditional virtual machines and what are the differences and why you'd want to choose Docker over a virtual environment. We'll go through the advantages of working with Docker and the structure and how you would build out a Docker environment. And during that structure, we'll dig through the components and the advanced components within Docker. At the end of the presentation, we'll go through some basic commands and then show you how those basic commands can be used in a live demo. So with all that said, let's get started. So let's first of all compare Docker with a traditional virtual machine. So here we have the architecture on the left and right of a traditional virtual machine versus a Docker environment. And there are some things that you'll probably see immediately that are big differences. One is that the virtual environment has hypervisor layer, whereas the Docker environment has a Docker engine layer. And then in addition to that, there are additional layers within the virtual machine. Each of these really start compounding and creating very significant differences between a Docker environment and a virtual machine environment. So with a virtual machine, the actual memory usage is very high, whereas with a Docker environment, the memory usage is very low. If we look at performance, virtual machines, when you start building out particularly more than one virtual machine on a server, the performance starts degrading and starts getting poorer, whereas with Docker, the performance always stays really good. And this is largely due to the lightweight architecture used to construct the Docker containers themselves. If we look at portability, virtual machines just are terrible for portability. They're still dependent on the host operating system, and there's just a lot of problems that happen when you are using virtual machines for portability. In contrast, Docker was designed for portability, so you can actually build solutions in a Docker container environment and have the guarantee that the solution will work as you have built it, no matter where it's hosted. Finally, boot up time. The boot up time for a virtual machine is fairly slow in comparison to the boot up time for a Docker environment, which is almost instantaneous. So we look at these in a little bit more detail. One of the other challenges that you have with a virtual machine is that if you have unused memory within the environment, you cannot reallocate that memory. So if you set up an environment that has 9 gigs of memory that's being used, but you have 6 gigs that are free, you can't do anything with it. Though that whole 9 gig has been allocated to that virtual machine. In contrast with Docker, if you have 9 gigs and 6 gigs becomes free, that free memory can then be reallocated and reused across other containers used within that Docker environment. Another challenge is running multiple virtual machines in a single environment can lead to instability and performance issues, whereas Docker is designed to run multiple containers in the same environment and actually gets better the more containers you run in that hosted single Docker engine. Portability issues with a virtual machine is the software can work on one machine, but then when you move that VM to another machine, suddenly some of the software won't work because there are some dependencies that haven't been inherited correctly. Whereas Docker itself is designed specifically to be able to run across multiple environments and to be deployed very easily across systems. And again, the actual boot up time for a VM, it just takes a long time. You're talking about minutes in contrast to the milliseconds that it takes for a Docker environment to boot up. So let's dig into what Docker actually is. So Docker itself is an OS virtualized software platform, and it allows IT organizations to really easily create, deploy, and run applications as what are called Docker containers that have all of the dependencies within that container very easily. And the container itself is really just a very lightweight package that has all the instructions and dependencies such as frameworks, libraries, bins, etc., all within that container. And that container itself can then be moved from environment to environment very easily. If we to look in our DevOps lifecycle, the place where Docker really shines is in deployment, because when you're actually at the point of deploying your solution, you want to be able to guarantee that the code that has been tested will actually work in the production environment. But in addition to that, what we often find is that when you're actually building the code and you're actually testing the code, having a container running the solution at those stages is also a really good plus, because what happens is that the people building the code and testing the code are able to validate their work in the same environment that would be used for the production environment. So really, you can use Docker in multiple stages within your DevOps cycle, but it becomes really valuable in the deployment stage. So let's look at some of the key advantages that you have with Docker. Some of the things that we've already covered is that you can do rapid deployment, and you can do it really fast. The environment itself is highly portable and was designed for that in mind. The efficiencies that you'll see will allow you to run multiple Docker containers in a single environment as compared to more traditional VM environments. The configuration itself can be scripted through a language called YAML, which allows you to be able to write out and describe the Docker environment that you want to create. This in turn allows you to be able to scale your environment very, very quickly. But with all of these advantages, probably the one that is most critical to the type of work that we're doing today is security. You have to ensure that the environment you are running is a highly secure but highly scalable environment. And I'm very pleased to say that Docker takes security very seriously. So you'll see it as one of the key tenets for the actual architecture of the system that you're implementing. So let's look at how Docker actually works within your environment. So Docker works, there is what's called a Docker engine. The Docker engine is really comprised of two key elements. So you have a server and a client, and the communication via the two is via a REST API. The server, as you can imagine, has the instructions that are communicated out to the client and instructs the client on what to do. The connection between the client and the server, the communication, is via a REST API. On older systems, you can take advantage of the Docker Toolbox, which allows you to go ahead and control the Docker engine, the Docker machine, Docker Compose, and Kitematic. So let's now go into what the actual root components, though, of Docker are. So let's have a look at those key components. There are four components that we're going to go through. We have the Docker client and server, we have Docker images, we have the Docker registry, and the Docker container. We're going to step through each of these one by one. So let's look at the Docker client and server first. So the Docker client and server is a command line instructed solution where you would use terminal on your Mac or command line on your PC or Linux system to be able to issue commands from the Docker Daemon. The communication between the Docker client and the Docker host is via a REST API. So you can do similar communication such as a Docker pull command, which would send an instruction to the daemon, which would then form the interaction of pulling in the correct components, such as an image or container or registry, to the Docker client. The Docker daemon itself is actually a service which actually performs all sorts of operating and performance services. And as you'd imagine, the Docker daemon is constantly listening across the REST API to see if it needs to perform any specific requests. If you want to trigger and start the whole process, what you want to do is use the command docker within your Docker daemon, and that will start all of your performances. And then you have a Docker host, which actually runs the Docker daemon and registry itself. So now let's look into the actual structure of a Docker image. So a Docker image itself is a template which contains instructions for the Docker container, and that template is written with a language called YAML, and YAML stands for yet another markup language. It's very easy to learn. The Docker image itself is built within that YAML file and then hosted as a file in the Docker registry. The image is really comprised of several key layers. And you start with your base layer, which will typically have your base image. In this instance, it's your base operating system, such as Ubuntu. And then you would then have layer of dependencies above that. This would then comprise the instructions in a read-only file that would become your Docker file. So let's actually go through and look at what one of those sets of instructions would look like. So here we have 4 layers of instructions. We have a from, pull, run, and then command. So what does that actually look like in our layers? So to break this down, the from creates a layer which is based on Ubuntu. And then what we're doing is we're adding in files from the Docker repository onto that base command, that base layer. And then what we want to be able to do is then say, okay, what are the run commands so we can actually then build the container within the environment. And then we want to be able to then have a command line that actually executes something within that container. And in this instance, the command is to run Python. So one of the things that we will see is that as we set up multiple containers, each new container is a new layer with new images within the Docker environment. Each container is completely separate from the other containers within your Docker environment. So you're able to create your own separate read-write instructions within each layer. What's interesting is that if you delete a layer, then the layer above it will also get deleted. So what happens when you pull in a layer, but something has changed in the core image? What's interesting then is that the actual main image of itself cannot be modified. Once you've copied the image, you can then modify it locally, but you can never modify the actual base image itself. So here are some callouts for the components within a Docker image. So the base layer are in read-only format. The layers can be combined in a union file system to create a single image. The union file system saves memory space by avoiding duplication of files. And this allows a file system to appear as a writable but without modifying the file, which is known as a copy on write. So to be able to get around this structure within a Docker container, the Docker environment itself uses what's known as a copy on write strategy within the images and the containers themselves. And so what this allows you to do is you can actually copy the files for better efficiency across your entire container environment. The copy and write strategy does make Docker super efficient, and what you're able to do all the time is keep reducing the amount of disk space you're using and the amount of performance that you're taking from the server. And that's really, again, a key element for Docker, is just this constant ability to be able to keep improving the efficiency within the actual system itself. All right, so let's go on to item number 3, which is the Docker Registry. So the Docker Registry itself is the place where you would host and distribute the different types of images that you have created or you want to be used within your environment. The actual repository itself is just a collection of Docker images, and those Docker images are built on instructions that you would write with YAML and are very easily stored and shared. And what you can actually do is you can actually associate specific name tags to the actual Docker images themselves. So it's easy for people to be able to find and share that image within the Docker registry itself. One of the things you actually see as we go through the demos, you actually see us actually using the tag name, and you'll see how it is an alphanumeric identifier and how we actually use it to actually create the actual container itself. One of the things you can do to as start off how you would manage a registry is you can actually use the publicly accessible Docker Hub registry, which is available to anybody, but you can also create your own registry for your own use internally. The actual registry that you create internally can have both public and private images that you create, and this may be for various reasons of how you structure your environment. The actual commands you would use to actually connect to the registry are both push and pull. Push is to actually push a new container environment that you've created from your local manager node to the remote registry, and a pull allows you to pull a new client that has been created and is being shared. So again, pull command, it pulls and retrieves a Docker image from the Docker registry and makes it very easy for people to share different images consistently across teams. And a push command allows you to take a new command that you've created, a new container that you've created, and push it to the registry, whether it's Docker Hub or whether it's your own private registry, and allow it to be shared across your teams. Some key did you knows in Docker Registry, deleting a repository is not a reversible action. So if you delete a repository, it's gone. So let's go into the final stage here, which is the actual Docker container itself. So the Docker container itself is an executable package of applications and its dependencies bundled together. So it gives all the instructions that you would have for the solution that you're looking to run. It's actually really lightweight, and again, this is because of the redundancy that's built into how you structure the container, and the container itself is then inherently also extremely portable. What's really good about running a container though is that it does run completely in isolation. So you're able to share it very easily from group to group, and you are guaranteed that even if you are running a container, it's not going to be impacted by any host OS peculiarities or unique setups as you would have in a VM or a non-containerized environment. The actual memory that you have on a Docker environment, they can be shared across multiple containers, which is really useful. Typically, when you have a VM, you would have a defined amount of memory for each VM environment. The challenge you start running into, though, is that you can't share that memory, whereas with Docker, you can easily share the memory for a single environment across multiple containers. The actual container is built using Docker images, and the command to actually run those images is a run command. So let's actually go through a basic structure of how you would run a Docker image. So you go into terminal window and you would write in Docker run Redis, and then it would run a container called Redis. So we're going to go in, and if you don't have the Redis image locally installed, it will then pull it from the registry. Then the new Docker container Redis will be then available within your environment, so you can actually start using it. So let's look at why containers are so lightweight. They're so lightweight because they really have been able to get away from some of the additional layers that you have in virtualization within VMs. And the biggest one is the hypervisor and the need to run on a host operating system. Those are two big elements. So if you can get rid of those, then you're doing great. So let's look at some of the more advanced concepts within the Docker environment. And we're going to look at two advanced components. One is Docker Compose, and the second is Docker Swarm. So let's look at Docker Compose. Docker Compose is really designed for running multiple containers as a single service. And it does this by running each container in isolation, but allowing the containers to interact with each other. As was stated earlier on, you would actually write the compose environment using YAML as the language in the files that you would create. So where would you use something like Docker Compose? So an example would be if you are running an Apache server with MySQL database and you need to create additional containers to run additional services without the need to start each one separately. And this is where you would write a set of files using Docker Compose to be able to help balance out that demand. So let's now look at Docker Swarm. So Docker Swarm is a service that allows you to be able to control multiple Docker environments within a single platform. So what you actually are looking at doing is within your Docker Swarm is we're treating each node as a Docker daemon, and we're actually having an API that's interacting with each of those nodes. There are two types of node that you're going to be getting comfortable working with. One is the manager node, and the second is the worker node. And as you'd expect, the manager node is the one sending out the instructions to all of the worker nodes. But there is a two-way communication that is happening. The communication allows for the manager node to be able to manage the instructions and then listen to and receive updates from the worker node. So if anything happens within this environment, the manager node can react and adjust the architecture of the worker node so it's always in sync. It was really great for large scaled environments. So finally, let's go through what are some of the basic commands you would use within Docker. And once we've gone through all these basic commands, we'll actually show you a demo of how you'd actually use them as well. So if we're going to go in, probably the first command is to install Docker. And so if you have yum installed, you just do yum install Docker, and you'll install Docker onto your computer. To start the Docker daemon, as you want to do systemctl start Docker. The command to remove a Docker image is docker rmi and then the image ID itself. And that's not the image name, that's the actual alphanumeric ID number that you want to grab. The command line to download a new image is docker pull and then the name of the image you'd want to pull. And by default, you're going to be pulling from the Docker default registry that will then connect to your Docker daemon and download the images from that registry. The command line to run an image is docker run and then the image ID. And then we have the, if we wanted to pull specifically from Docker Hub, then we would have Docker pull and then the image name and colon its tag. To build an image from a Docker file, you would do docker build-t and then the image name and colon tag. To shut down the container, you would do docker stop container ID. The access for running a container is docker exec it container ID bash. So we've gone through all the different commands, but let's actually see how they would actually look, and we're going to go ahead and do a demo. So welcome to this demo where we're going to go ahead and put together all of the different commands that we outlined in the presentation for Docker. First is just to list all of the Docker images that we have. So we do sudo docker images and we enter in our password. And this will now list out the images that we've created already. And we have 3 images there. So let's go ahead and pull a Docker image. So to do that, we'll go ahead and type sudo docker. And actually, we don't want to do image. We want to select pull and then the name of the image that we want to pull, which is going to be MySQL. And by default, this is actually going to go ahead and use the latest MySQL command, MySQL image that we have. So it's now going to go ahead and pull this image. It's going to take a few minutes depending on your internet connection speed. It's kind of a large file that has to be downloaded. So we'll just wait for that to download. You can see the others have completed. Just waiting for this last file to download. Almost there. Once that's done, what we're going to go ahead and do is we'll actually run the Docker container and create the new container using the image that we just downloaded. But we have to wait for this to download first. Alright, so the image has been pulled from Docker Hub. And let's go ahead and create the new Docker container. So we're going to do sudo docker run -d -p 0.0.0.0 :80 :80, and then we'll put in MySQL latest, so we have the latest version, and we have our new token, and that shows our new Docker container has been created. Now let's go ahead and see if the container is running, and we'll do sudo docker ps to list all the running containers. And what we see is that the container is not listed there, which means it's probably not running. So let's go ahead and list out all of the images that we have within Docker so we can see whether it's actually listed there. So we'll do ps-a. And yes, there we are. We can see that we do have our new container, MySQL latest, and it was created 36 seconds ago. But it's in the exited mode, so what we have to do is we have to change that status so it's actually running. So let's change that to running state. We'll do sudo docker run -it -name, and we can name it SL SQL MySQL /bin/bash, and that's now going to be in the root, and we'll exit out of that. And now if we list out the Docker containers, we should see it is now an active container. Sudo docker start, and then we'll start the saying it, and we should now see it. There we are. It's now in the running state. Excellent. And we can see that it was updated 6 seconds ago. We're going to go ahead and we're going to clear the screen. Okay, now what we want to do is remove the Docker container. So what we're going to do is check list of images that we have. And so sudo docker images here are the images that we have, and we have MySQL is listed. And what we want to do is delete MySQL. And to do that, we're going to type in sudo docker rm-f image MySQL. Run that command, and what we'll find is the image. There's no such image. Oh, okay. So what we actually have to do is we have to go and see that the image is now gone. It's been removed. Excellent. It's exactly what we wanted to see. And we can also delete an image by its image ID as well. However, if an image is running and active, we have to kill that image first. So we're going to go ahead and we're going to select the image ID. We'll copy that. And it's going to, we paste that. It won't be able to actually run correctly because the image is active. So what we have to do now is stop the image and then we can kill it. So it's in the running state. So we have to do, so we do sudo docker kill and kill SL, and that will kill the container. And now we'll see that the container has gone. And now we can delete the image. And that's going to be the image gone with the image ID. Ba-boom. Easy peasy. Okay, let's go ahead onto the next exercise, which is to, so here we are, we've listed all of the containers and they're all gone. So let's go on to the next exercise, the final exercise, which is to actually create a batch image. And we're going to do a batch HTTP image. So let's go ahead and write that out. So it's going to be docker run dash dit dash dash name white. That's going to be the name of this HTTP service dash p 8080:80 dash v open quotes $pwd close quotes colon slash usr slash local slash apache2 slash htdocs slash httpd semicolon 2.4. We run that. Put in our password again. So what we see is the port is already being used. So let's go ahead and see which ports. Let's go see if we can change the port or see what ports are running. So let's do sudo images and see which ports are being used, because it's either the port or the name hasn't been put in correctly. So sudo docker images ps sudo docker ps-a, and yep, there's port 80 there. So we'll clear the screen. So we're going to change the container name because I think we actually have the wrong container name here. So let's go in and change that, and we'll paste that in, and voila. There we go. Now working, and we'll just double check and make sure everything's working correctly. So to do that, we'll go into our web browser and we'll type in, as soon as Firefox opens up, type in localhost :8080, which was the port that we created. And there we are. It's a list of all the files which shows that the server is up and running.
Now let's talk about what exactly is in Dockerfile here. Now Dockerfile is a concept which is being used as a build script. So it's being used so that we can have a build script there. So this will definitely helps to see that how we can go for a build of a Docker image, a custom Docker image. Now when we are using the Dockerfile concept, so it really helps to prepare a kind of Docker image. So doc image is the end result when you are going for the mechanism, when you're going for the Dockerfile build up here. So Dockerfile is a build script which is available for preparing the custom Docker containers, because not every Docker image is available on Docker Hub. So some containers you have to use, some images you have to use to work on that part. Now Dockerfile is a very simple, straightforward text file which is available there, and it's basically used to build up custom Docker images. So Dockerfile is basically used to prepare so when you're running the Docker build, so it's actually going to build up a particular custom Docker image, and that will be given to you. So Docker image is the whole build process which is being done. So it's a custom process which is available and being done over here in this case. So you got a Docker file, you run the Docker build command, and that's how you will be able to get a Docker image. So whatever the steps you are having in the Docker file, that will be processed one by one, and as a end result, you will be able to get a full-fledged Docker image over here in this case. Right, now let's talk about the syntax of the Docker file. So Docker file is equal to commands and the arguments. So whatever the things you want to put up, so in the Docker file you can do that, and as a part of the execution, so you will be able to get a particular end result. Now it's a kind of a mechanism where we feel that how the execution and the modifications can be done. So the comments which we are trying to do over here is that, you know, we can put up the whatever the comments we want to put in the case of Docker files, we can do that. Comments is a standard process in preparing any particular file or any kind of code, because it helps us to understand that for what reason we are preparing that particular line. Then we have the particular run statements. The commands are there, so you can see that we are running a particular command called echo. So using the run attribute, we are basically going ahead and running a particular command into our system as part of our Docker file over here. Now how to build up the Docker images using the Docker file? So you know, Docker file is just a template which is available there, where we are putting up that what are the different steps we want to follow, and these steps, when we follow one by one, step by step, so that's where we will be able to get a particular final Docker container over here. So Docker image is getting converted as a Docker container, and we are getting a Docker container as an end result. Now Docker file is being built up and stored in the version control system, and this particular Docker files, when we are processing, so it prepares a respective a specific image layer over here, and this image layer is something which is benefiting us, that how the executions can be done and how we can manage on that part. So that really helps us to see that how the executions and the things can be managed, and that can help us to see that how the management of the things can be performed as such. So Dockerfile is a very good concept which is there, using which you can prepare any kind of custom Docker image, and it can be very easily handled also, and it's a fully automated mechanism. You can use it inside the CI/CD pipelines for automating the Docker images. Right, now it's Docker image is a layer by layer mechanism which is there, in which we have multiple layers. Each and every layer we are doing some specific entry, some specific task, or some, you know, changes we are trying to deploy in part of these layers. Right, so you can use the particular Docker build command to perform the executions, and you will be able to get a particular response, and output will be given back to you. So Docker file is basically helping you to see that how the executions can be done, and you will be able to get an end result over here. So the Docker image is the final result which we are getting when we are talking about the Docker file here. Right, so these are all read-only formats which is available. You cannot modify these directly, but yes, with the help of Docker file, you can do whatever the changes you want to deploy on these Docker images. Right, so this is a small example where we are using a base image as an Ubuntu 18.04. So we are using the from attribute to specify that yes, we are going to use the Ubuntu 18.04 here. Then we are pulling the file into the directory. We are transferring a particular file inside the Docker container, and then we are running a make command, and then cmd attribute is there, using which we can run the command on the runtime on the Docker container. So these are a very basic example, but eventually when we are done with this Docker image, we will be able to get a 4-layered Docker image over here, because there are 4 steps, and then hence it will be providing you a particular 4 layers in your final Docker image over here. So layer by layer these changes will be done during the build process, and in fact using the Docker history command you can see the layers, these layers information also. right? So layer 1 is Ubuntu 18.04, layer 2 is pull, and the third layer is there where we can run the make command to run this file which we have pulled on. And then finally the last one is there where we are running like using the cmd parent. So the difference between run and cmd is that cmd will run only when you run a docker container. So run attribute will be executed during the docker build part. So this is pretty much is a way that how we can go for the execution of a Docker file, and how we can go for the build up of a custom Docker image over here. So these are the some couple of attributes which we are using in the Docker file here. Right, now let's talk about the entry point over here. Now entry point allows you to specify a command along with the parameters, right? So let's say that you want to run a particular command over here in the Docker container. So entry point is something which you can use to refer to that. So application is the command which you're trying to run, and then you can give some arguments to that, and argument 1 is what you're trying to run over here. So entry point is very important because that eventually helps to see that how the executions can be done, and the implementations will be done over here in this case, right? So you can see like you can run a command called echo, and then you can use the parameters also. It's not like only the commands can be used, but you can in fact use the arguments also. Now add is an attribute which is available in the Docker file, which is primarily used to transfer the files from the host machine inside the Docker image. Now let's see that you are trying to prepare your own custom Docker image. Apart from the dependencies, you need the source code also, right? So the source code needs to be transferred inside the Docker image, and for that reason we can use the add attribute. So add attribute requires a source and destination. Source will always be the path on which on the host machine the files are present, so we can give that. And destination is the folder which is available inside the particular Docker container where we want to store the files. So you can use the example over here just like this. You can use, and you can give two entries. One is the source, one is the destination. And once that is done, so you will be able to see your files being stored up in the destination directory once the final Docker image is prepared. Then we have env attribute. Now env is something which is used to set up some environment variables, which is required of course for the Docker image, for the application which is running inside the Docker image. Now environment variables are something which you can hardcode during the Docker build one, but using the when you are running, like when you're creating the Docker container, at that time also you can override these environment variables. So environment variables are very important because first during the build process you can hardcode some values, but if you really want to change them during the runtime, that also is being supported by the environment variables. So most of the times we use it as a kind of a key value pair, just like in Linux we use to set up a particular environment variable. So the key value pair is being used in case of env attribute. Maintainer is there where we can describe that what is the details about the author. These are the fields which is available in the top, so where we can give the author name and the author details like email ID and all, so that we know that who is the person who is maintaining this particular file, and we can reach out to them in case any issues are there for the Docker files here, right? So that is what we have here in this one. So now we are going to see that how we can go for a small demo on Docker file, and we can go for the implementation of this particular Docker file and prepare a custom Docker image. So let's just wait on that part. So let's see some demo here. Now in this one we have got two examples. One is a Python, one is a Node.js one. So first of all, what we need to do is that we need to process the Python one here. So this is the sample Docker file which we have got here for the Python. Now all this one requires a Python file which is already present on the server, and we are going to transfer, we are going to copy this content over here. This is the specific Docker file content which is available to us, and all we need to do is that we need to put this content across the server so that we will be able to build a custom Docker image. So let's go back to the server. So here we have already got the Python file which is present. So we have to create a Docker file here which will have the steps related to the Docker image preparation over here. So we will be including some steps over here, that these are the different steps we want to configure, we want to set up over here in this one. So Python 3.6.4 is the version of the Python which we want to configure, and then we are going to transfer some files into /app. We are also setting up the working directory as /app, and ultimately we are running a command called pip install flask to do the installation of Flask package, and then we are starting the specific applications on that part. So I'm going to save this file, And once I save this file, so all we need to do is that we need to create a custom Docker image, right? So right now there is no image which is available over here, and it's in complete empty instance. So I'm going to run a command called docker build -t python -am dot. So docker build is the typical command, but -t is for the tag that what kind of Docker image you want to build, and then we are giving a image name, and then we are specifying dot over there. Now once we are done with that, so it will pick up all the things one by one. The basic Docker image is being pulled down, then some sequence of steps is being executed. So it's a step-by-step process which is happening over here in this case, and we are then transferring some files in the /app, and then ultimately we are going for the pip install flask, so it's installing those packages, and at the end the final Docker image will be prepared and will be given back to us. So we will be able to get this Docker images over here. When we run that command, we will be able to find out that we got our custom Docker image also available. And as you can see that the base Docker image is also available in this one, but yes, we have added up like around 10 MB of work we have added on top of this Python base Docker image here. So that's how we are able to do the processing over here in this case, in this setup. So that's what we can do to prepare a custom environment of Python with the help of the Docker file here. Now let's see that we will be proceeding on with the Node.js to see that if the Node.js kind of setup also can be done. Now for Node.js, again, of course, we got the specific Docker file which is present, so we can process that. But let's create a new folder over there. So I'm going to create for a new Node.js folder so that we can create the work all together in this one. So I'm going to run a command called npm init, which is the command to initialize any empty project in case of Node. Now you can typically bring down some real code also, or you can say that I want to process an empty project. So you can give the configurations, you can give the custom names, but I want to process with these default name itself. So ultimately it's going to create an entries like you will be able to see like all these values which we are not providing. These standards value will be picked up for the specific code, and at the end you will be able to get a package.json file created over here in this one. Now you can actually bring down the steps that how you can perform, or you can build up a custom Node.js based Docker image. Now these Docker files is giving you the capability that you can convert a full-fledged application which is deployable on the virtual machine. You can actually convert them in the format of the Docker containers over here in this one. So that's what we are going to get over here with this particular setup or these mechanisms. So let's go back to the document and see that what exactly we can copy the Docker file. So we have got this Docker file over here. So all we can do is that we can copy this one. So once we copy this specific file here, so all we can do is that we can transfer these files into the onto the server. We can convert it into the Docker file there, so that we will be able to set up the configurations and we can perform the setup around that. So Docker file is again we want to create and we want to set up on that here. So let's go back to the server. So here we want to create a Docker file, and we want to set up the files inside that. These are the different files which is being available, which is being configured over here in this one. So we are running like node server.js, which is the master file. So we are doing an expose of 8080. Then of course we have copy commands which is there, then npm install command is there, and then package.json file is also there. Now what you need to really do is that you need to go for a server.js file which is available, in which you can configure that how the setup needs to be done and how the configurations should be performed there, because that's a command, that's a script which is going to be executed within the container. So let's copy the content. Now I'm going to copy this content over here, which is like a sample Node.js code which is available. So I'm just copy this one and transfer it to the server. So server.js file we have to create here, just like we did in case of the Python, because this is the source we want to transfer inside the Docker container. So this is what we have got. Now I'm going to transfer like I want to change this port value from 5000 to 8080, because that's what it's configured in the Docker file. Of course you can configure 5000 also, depending on your requirement you can do that configurations. Now you have got these two files over here in this one. So all you need to do is that you need to run like docker build -t node.js -app and dot. So it will automatically pick up like what exactly it will go for the Node.js basic Docker image over here. So that will be processed over here in this one. So step by step it will be able to do the configurations. So first of all, it will download the basic Docker image, which is quite more in size over here in this one. Once it's downloaded onto your system, then it will proceed further with the build activity on processing the Docker file, performing the execution. So all that stuff will be performed with this help of this Docker build process over here. So it's going to process it one by one in this one. And it's going to the next step where it's transferring some of the files, like creating some working directory, transferring the files, putting up there and running the npm install command, and then ultimately it will expose the port, and then it will have the cmd attribute configured over there. So this is basically typically trying to portray that how a particular Docker image can be built up. And of course, once the build is success, you can validate it with the help of Docker images here. So this is the app Docker image which is being prepared of 911 MB, and we have got it like a final package where the runtime is also there and the code base is also available. Now you can pretty much experience it like with other actual source codes, like you can download some pre-configured Node.js websites or the source codes here, and you can try to run them onto the Docker container so that you can get the full the complete idea about that how it goes on. But right now these are the basic Docker image which you can prepare and you can build up over here in this one. So that's how it really works on for you. Now let's begin with what exactly is in Docker, because we are trying to explore that what are the different Docker commands we can eventually run to interact with the Docker, because you have the command line interface which is available there, using which you can run some couple of Docker commands, and internally you will be able to have some particular processing which is done at the Docker end. Now Docker is a configuration management tool. It's being used as a configuration management tool just like the other configuration management tools in the industry, in the market. Now it's pretty much used by the developers to make sure that they wrap or they package an application with all its dependency. Now normally in a virtual machine, what we do is that we host or we install the dependencies separately, and then on top of that we host our web applications, or whatever the application we have, we host it on that particular framework or platform. But here in this scenario, we are talking about like how we can wrap an application all together with its dependencies. All the dependencies are getting wrapped, are getting packaged up into a single entity, and that's what we call it as a Docker container. So Docker is a configuration management tool and a containerization tool which is there, which helps us to wrap or package both the dependencies and the source code within a single unit called Docker container. And this is the Docker container which the developers use to do the deployment across multiple environments. So as part of the process, when you are working on the hosting of your application onto your Docker, so ultimately you are looking forward for an entity called Docker container. So if you go through the diagram over here, so in this one, this is in kind of a basic way architecture that how the Docker is being architect and is getting deployed. So initially you have an infrastructure, like a physical infrastructure is there. You have the particular cores, memory, infrastructure, all those things are available there. Now on top of this infrastructure, you are hosting up a host operating system. This host operating system is responsible for taking up all the requests and interacting, providing a particular interface between the particular Docker and the infrastructure, the core hardware. So it acts like a medium over here. So after the host on operating system, on top of that you are going to install the Docker engine, Docker software. It's just like you got a virtual machine on Linux, and on top of that you are installing the Docker software. Once the Docker engine is installed, then Docker engine will take care of management of the Docker containers. You don't really have to do a lot of work. Docker engine is going to take all the internal work, the communication between the operating system and the infrastructure, so that needs to be done by the Docker engine. So Docker engine makes sure that the different container gets up and running, and you can see that in this scenario, in this diagram, we have container 1, container 2 and container 3, and all these containers are actually having its own applications and the dependencies binded up together. So that's the reason why we are saying that with the Docker we are getting a complete package, end-to-end package is being given to us, in which we have both the particular source code and the binaries and the executables embedded inside that. So it's a complete package which is getting created in the form of Docker container, and the developer is responsible for preparing this Docker container so that these containers can be deployed on the Docker host and you can get your application up and running. So this is what we have Docker into a particular and the architecture of the Docker here. Now let's see that what are the different commands we have for the Docker here. Now the very first one is that what are the different images related commands which is available there. The very first one is the command which we typically use to prepare a custom Docker image. Now I can easily go to the Docker Hub and I can pull down a Docker image which is available there. But let's assume that you are working on application source code. So you want to prepare a Docker container for that. Now that Docker container, you will not be able to have it on the Docker Hub. You have to prepare on your own, right? So in order to prepare your own Docker image, all you have to do is that you have to run docker build command. Now in this case, we have to prepare a Docker file which will act like a kind of a Docker build script. Just like in case of Maven, we have pom.xml file, and in case of and we have build.xml file. So here we have the Docker file which is available there, and this Docker file makes sure that whatever the steps are mentioned in this Docker file in the build script, it's going to perform a series of steps and the build will be done. So Docker build is the command. -t is the tag that what exactly name whatever the image you are building. So what exactly tag name you're trying to provide over here. So here we are using a tag name called my image, and then after the colon we are providing that what version we want to go here, 1.0, 2.0, 5.0. so whatever the version you feel that you want to refer, you can do that. Now this is the exact way that how in the actual world the Docker images are getting built up by the respective vendors. Let's say that Jenkins wants to prepare a Docker image. So they will be preparing the Docker file in the same manner and prepare these Docker images and publish it to the Docker Hub. So all the Docker images are built up, the custom Docker images are built up with the help of Docker file. So Docker build is the command which will process the Docker file and give you a particular Docker image in the end. Now how to list down all the Docker images. So Docker list ls is something which is there. So this will eventually help you to list down all the Docker images which is listed on or which is available into your system. So that will be listed out over there for you. If you feel that you want to remove a particular image, in that case you can go for docker image rm command, and whatever the image you want to remove, you can give the respective image name and the tag name there. So docker image rm command is there, using which you can actually see that how the image can be deleted from the host over here in this one, right? So whatever the ways, whatever the mechanism is there, so we are making sure that how the image can be built up and how we can go for the built up and a particular image can be deployed over here in this case. So in order to delete an docker image, so you can go for docker image rm command to remove a docker image completely from the Docker host. So these are some couple of commands which is available there, using which you can actually interact or manage the Docker image. Because in order to prepare or in order to run a Docker container, we require a source, and that source we are going to get it from the Docker image.
So now we are going to see that how we can execute these commands. So first of all, what we need to do is that we need to see that how Docker build works. For that, we require a Docker file. So I'm going to have a simple Docker file over here, in which we are going to have a basic Docker image selected as an Ubuntu. After that, we are going to go for the run attribute, where we are going to do the installation of a specific package, like let's say Git. And accordingly, you can, whatever software you want to prepare, you want to set up, you can do that and put up the commands over here in this Docker file. So I'm going to save this file, and after that what I need to do is that I need to run like Docker images to find out that how many images are there. There is no images present, so I'm going to build a Docker image over here with the name of Simplilearn, or whatever the name you want to give. You can give it over here. In this case, it's not any kind of restricted word, so you can give the actual Docker image name also, that what for what purpose you are preparing this image. And with that, what will happen that it will take up the values, whatever attributes you have put up into the Docker file. So that will be processed and that will be picked up. And once that Docker file has been processed, has been prepared, you will be able to see that yes, a final product or a final Docker image is finalized and prepared over here in this one. So we just have to wait for the whole process to complete, and once my Docker image is prepared, I will be able to have a particular setup done or achieved over here. So that's what we require over here in this one to be performed. Now once the installation is done, so you will be able to see like the final Docker image is being prepared over here. So it says successfully built, which means that the Docker image is prepared. Now if you run like Docker images, you will be able to find out that this image is available over here in this one. Now you are seeing like two images, because one is like the basic image which is being pulled down, because we are using a Docker file to do that, to process that one there. Now in case you want to remove it, so all you need to do is that you need to run like Docker image rm and Simplilearn. So if you do that, what will happen, that your Docker image which is related to Simplilearn will be wiped off from your system. And in case you want to do like removal of the Ubuntu also, so that also you can do over here with the help of Docker image rm Ubuntu, and that will be removed from your system. So your Docker images will be removed from your system using the particular command called Docker image and then rm command to remove the Docker image from your system, from your host here. So that's how you deal with the different Docker images commands over here in this one. Now let's go back to the document.
Now the next section over here is the Docker container commands over here. So all the commands related to Docker containers is what we are going to talk about over here. Now the very first one is the particular container. So in order to create a container, so you can run the command called docker create and the image, because for a container you require a Docker image. That's a prerequisite. So once the Docker image is prepared, you can just simply run docker create command, and that will help you to create a container onto your system. Now if you want to run a particular you want to create a container and you want to run it out also at the same time, so in that situation you can go for docker run command. The main difference between the docker create and docker run command is that the docker run command is going to run a container, and it's going to give you a response from the command, but the docker create command is going to create only the container. So once the container is up and running, so that's only being done by the docker create command. But the docker run command is going to actually do the preparation of the container also, and at the same time you are being given as in particular response also, like what a command you want to run, so that response also you will be able to get here. And if you feel that you want to rename an existing container, so for that you can go for the docker rename command. So existing container you can rename it with a new container, and that's how the particular rename of an existing container will be done with onto the Docker host here. So docker rename is the command using which you can rename an existing container and you can get a new container over here in this case. So these are some of the options, some of the ways that how you can interact with the containers, how you can manage them onto your Docker host over here. So you can run it, you can create it, and you can rename the containers also.
So now what we are going to do is that we are going to see that how we can work on this particular container commands here. So first of all, I'm going to quickly pull down a Jenkins image so that I can create a container out of that. So it's in kind of a 600 around MB Docker image which is available there. Now you can also have a custom Docker image prepared using the Docker file, or you can have a ready-made Docker image pulled down from the Docker Hub also. So this is going to pull the latest version of the Jenkins from the Docker Hub, so that we will be able to proceed further on that, and we will be able to continue with the hosting. So we will be converting or running this specific Docker images in the form of Docker containers, so that we will be able to have instance of Docker container over here running in this one. So that's what we are trying to do here. So we will just wait for this pull activity to complete, because it's an heavy Docker image, so it may take some time to download. And once it's download, you will be able to see that Docker images is showing a specific Docker image of Jenkins here. Now you're going to create a container out of that. So you're going to run a command called docker create and Jenkins over here. So that will help us to do the creation of a Docker container. And once that is done, so you will be able to see, like using docker ps command, that if any container is up and running, and if you go for docker ps -a, you will be able to see that yes, a particular Docker container is in created mode. Now this is not in running mode, because you see that when I ran the docker ps command, it was not showing it in the running mode, because I just created a docker container here, and the created status also shows that yes, the docker container is created, but it did not run over here. So if you want to run it, so definitely you can say like docker start, and you can give the container name, and that will help me to start my container over here. But of course, if you feel that you want to directly create a container, and you don't want to create the container only, you want to start it also, so in that case you can go for the docker run command. So docker run command is something which can be used instead of doing the execution. So you can say like docker run jenkins, and what it will do, it will definitely help you to get the container created onto of the jenkins over here. In this case, it's not like only creating a container, but in fact it's actually starting the container also. So you can see that it started over here into your screen itself, that whole jenkins gets initialized over here in this one. So this is the way that how you can initialize or you can create a container. Now I can just do a control C over here, because it says that jenkins is up and running. So you can start using this one according to your requirement over there, right? So I'm just doing control C so that it can be stopped over there, right? Now, so this is the way that how typically we can create the containers. Now we got like two containers over here, and one is up and running, and one is something which I just closed just now over here. Now if you feel that you want to rename a container, let's say like this is a container which is available, but it's not having a meaningful name. Now I want to convert it into a meaningful name like dev_jenkins. So that you can easily do with the help of docker rename command, because that will rename the docker container name, so that you will be able to connect on to that and you can go for the processing. So that's what we can get over here in this one. So this is how you can do the various management of the resources over here. So let's go back to the main content.
Now, if you feel that you want to remove all the stopped containers, because what happens that sometimes we simply stop the container, but we do not remove it from the Docker host, because we are not going for the cleanup. Now, cleanup is very required, because these containers are actually taking up the disk space also. So we need to make sure that we should be having like minimum amount of disk space utilization. So for that, what we really need to do is that we need to run docker container prune command. So this will basically help you to prune or do the cleanup purge of all the containers which is running on the host machine here, and that will definitely help us to remove all the containers which is in stop status. So that will be simply removed over here in this one. So this really completely removes all the stopped containers onto the Docker host over here in this scenario. Now second one is that it creates a new image from a containers file changes. Now the way what happens that normally what we follow is that we use the docker build command to do the build process, right? So docker build command is being used in that particular way. Now if you really want to go for preparation of a new image, so all you need to do is that you need to create a new image from a container file. So you can run the command called docker container commit command, and whatever container is there, so that will be saved or preserved as a docker image. Because sometimes we also do some ad hoc changes or modifications on the fly inside the docker container by going inside the docker container and doing the steps. So we really need to preserve those steps, and that is the reason why we are converting a docker container in the form of a docker image here. So that's what we are trying to perform here. So docker container is something which is being done over here in such a way that whatever the steps, whatever the changes we are trying to do, so that needs to be performed over here in this case. So docker container commit command is being used so that we can get a particular final image as part of the container. So the container will be converted in the form of a docker image over here. And the last one is that how we can remove an existing container. So we can go for the docker rm command, which is available there, using which you will be able to go ahead and you can get a particular container removed from your existing system. So docker rm command is pretty much there, using which we can see that how we can remove an existing container from your system as such.
What exactly now we are going to see that how we can perform the various commands on the containers here. So the very first command which we want to do here is that, in order to see that how we can actually remove all the stop containers. But for this one, what we really need to do is that we need to first of all run some couple of containers. So I'm going to quickly run a container called Docker run -d httpd. So I'm going to run a particular web server over here, and it should be able to give me a proper container up and running. So I can just double check or validate it as with the help of the docker ps command. So docker ps command should give me the proper confirmation that whether the container is in up and running over here or not. So you can see that it's up and running from last 11 seconds here. Now we got a command where, for example, we have got some stopped containers, but again you have to manually remove them one by one. Now if you don't want to do that stuff, if you feel that whatever the stopped containers which is available, that should be automatically removed from your system, then we have a command called docker container prune. Now for this, what we really need to do is that we need to actually stop this container, because again it will be only picked up like whatever the containers which is available in the stop status, only those will be picked up. So I have copied the container name here in this case, and I need to stop it so that I will be able to remove it with the prune command over here in this one. And then I can run like docker container prune command, which will basically remove all the containers which is in the stop status. And once that is done, you will be able to see like that is something which is completely gone from your system. So this is a way that how it can not only take care of the stop containers, but it's actually being done so that you can remove the multiple containers with a single command itself over here. So this is not something which will be executed one by one on a different container, but yes, it will definitely take care of doing the changes and performing the activities. Now another thing is that how we can actually do the commit of a particular Docker image. Let's say that we got a Docker container which is running, and there are some changes like some dynamic changes which is available there. So you want to save this particular container as a Docker image, so that whatever the changes, temporary changes are there, so that will be also saved as a Docker image. So all you can do is that, let's say, let again run a particular container of HTTPD here. So this will help me to get a particular container from the HTTP perspective available to us. So docker ps command will give me the option. Now here I have got a container in which it's running. Now if I want to save this container, let's say that I went inside it, did some modification, did some temporary changes. Now I want to refer it, I want to use it. So how you can do that? So for that, what you really need to do is you need to run like docker commit. That's a command, or you can say docker, because you're going to do a docker container commit over here. So the commit of the container is what we are going to do. So docker container commit, and then we are going to say like what is the container. So for container we will be again copying that particular container ID, and we'll say like custom image colon version 1. So we will be giving a custom name or a name of a Docker image and a tag over here in this one. So this will basically save my Docker container which is available in this one in the format of a particular Docker image, in a format of a Docker image over here in this case. So as you can see that almost both of them are having the same change, but the container which we got over here in this one, so this whatever the changes you want to do, you can do that, and you can then put it up into the form of a Docker image, a final Docker image. And at last, if you want to remove it, so docker rm and container ID. Now this again docker rm will come remove only those containers which is in stop status. So if you want to forcefully remove it, so you will be able to use it with the help of -f, which is the forceful remove, which will remove the container completely from your system. And once it's removed from your system, you will be able to see like there is no container running up and running over here in this one. So docker ps -a is not something which is up and running over here in this one. So the completely got wiped out from your system. So that's how you basically work on these commands on this particular container related commands here. So let's go back to the main content.
right? So these are the commands where we can actually do the management, like how to stop the containers, how to remove the containers, and how to get a new Docker image out of the container here. Now let's see that how we can list down all the running containers. If you feel that you want to list down all the running containers, then you can go for the docker containers ls command, and that will eventually help you to list down all the containers which is available there, which is being there into your system. Then docker stop command is there to stop a container. So whatever container which is there in the running status, so that will be stored with the help of the docker stop command. And then the restart command is there, using which you can do a restart of a container into your system, right? So once the container is restart, so whatever the application running inside the container, so that will also be restarted over here in this one. So these are the different options which is available, using which we can explore over here in this one.
Somewhat more commands about the container. So again, I am going to run a container over here of HTTPD here, so that I can show you some couple of more commands over here. Now we can run like docker ps, or you can say like docker container ls will be list down on all the containers which is available to you, which is being present in this case. Now if you want to do any kind of operations, like let's say if I want to stop it. Now the moment you do the stop over here, so you will be able to stop the container which is up and running for you, and you can come whatever the application is being deployed, that will also not be available to you, because that's simply completely gone for you. Now you can see that docker container list is not able to show you that particular option, that whether it's being shown or not, because it's in stop status. So in fact you can do a start, or you can do a restart. So both the operations you can pretty much do over here, so that you will be able to have a complete activity implemented. So restart is also something which is available, which can definitely help you to see that how the things really work, and how you can go for the container the management over here in this case. So you can do docker container ls command to list down what are the containers which is available. Then you can do a restart, you can do a stop also. In fact, start is also there, which can help you to see that how the containers is really available. So this is the way that how you can manage like even the restarts and all, because this really helps you to even do the restart or bounces to the application which is present inside this container. So that also you will be able to see with this particular component here. So that, let's go back to the main content. And then killing a running container. So if you really want to kill a container, so for that we can go for the docker kill, because docker stop is also going to stop the container. But if you want to forcefully kill it, so in that case you can go for the docker kill command to do that particular kill on the containers. And then if you really want to go inside the container and you want to attach your terminal, so for that you can go for the docker attach command, and with this what will happen, that you can go inside the container, you can do whatever the changes you want to perform, you can do that, and you can again come back outside that also. So normally typically we use it so that we can see some errors of in the logs which is coming up in the containers, and if any kind of issues are coming up for the applications, we should be able to know that part. Now the last one is the particular wait. Docker wait is there, so that will block a container, and it will go in the wait status. So docker wait and the container ID or the container name you can give. So with that, the particular container will go into the block status. Let's see somewhat more commands over here. So we can run like docker container ls again to find out like what container is available. So you can see that this particular container is available over here in this one. Now if you see, like if I want to get attached to this container, if I want to attach my input and output stream with this container, so you can run like docker attach and the container ID. So your terminal will be stuck over here, because it's taking up whatever the progress which is going to be done in the container, that will be in a kind of attached to your terminal over here, and you will be getting the output. But the moment you come out of this, like you say Control C, so you will see that it's basically sending the request to the container that it's getting stopped. So you will be able to see like the docker container list is not going to show you, because the container is in stop status. So again you have to do the restart of the container to make sure that the container is up and running, right? So the attach one will help you to go and attach your standard input and output with your container, with a running container. But when the moment you comes out, you will be able to disconnect or shut down the container. And again I had to restart that container over here in this one. Then again of course we have like docker wait then container is there. So this will basically put the container into a block status, because all the requests and all will be not sent to the container, and it will be blocked. And if you really want to like consume, or if you want to make use of the container, you will not be able to do that. So docker wait command will kind of block the container, and if you again try to come out of that, so again the requests to the container will be resumed, and they will be able to use on that part. So docker wait command is being used to block the container, and then we have docker attach to the container, the standard input and output. And lastly is the docker kill, which is going to kill the container, and you will be able to see that the container is in simply killed status. So it's it's not like a stopped over here. If it's gracefully stopped, then the exit code definitely will be 0, but in this case, since it's being killed, the particular status is 137 over here in this one. So that's a non-zero status code. So that's how way you will be able to manage the containers on different aspects. Let's go back to the main container. So these were some of the commands which was there from the Docker containers perspective. Let's talk about some of the commands from the share command perspective. So how we can share the Docker images. So we have a typical pull push mechanism which is there, using which we can actually interact with the Docker Hub or a Docker registry. So if you really want to pull a Docker image, so in that case you can go for the Docker pull command. If you want to push an image to the registry, so you can use for the Docker push command. If you want to execute a command inside a particular running container, or you want to execute a command or a script or something like that, so you can go for the docker exec command, and with that the execution will be done, and you will be able to get a response. So that will make sure that yes, whatever the execution you are trying to do, so that will be done over here in this mechanism. Now let's see that how we can do a pull and push activity to a Docker image. So first of all, the pull command is pretty simple. All you need to do is that you need to say that, okay, I want to pull a Docker image. If let's say that our Docker image is already present, then it's just going to say that it's already up to date, it's already available there. But if in some cases you feel that the Docker image is not available and you want to pull it, so all you can do is that you can give that Docker image name, and that you can give the tag also, but in this case we are using the tag as in latest. So that's the reason why even if you provide or you don't provide, it doesn't really matter. So I'm going to give like a Docker pull a MySQL over here, and the moment I hit on this one, what will happen that it says this particular Docker image is not available into my system. It's going to download it, and once it's going to be downloaded, you will be able to see that into your local system. So Docker images is something which is going to help you with the commands, and it will give you the particular ways that how the Docker image is available. So I can run like Docker images over here to see that what are the different Docker images which is available in this manner. Now if you really want to move any of the Docker image, then of course you have to do a Docker login, and you will be doing the the connectivity to the Docker Hub, and then establish the connectivity and all. So what you need to do is that you can run the Docker login command. We will also see this command in the next particular slide, but right now we are just doing it because we want to showcase that how the push really works. So you can actually give your username, that what username you are holding up. So the password does not shows any activity, but yes, still it will let you know that whether the login is successful or not. So in this case it says login is successful. So all you need to do is that, let's say like I got this custom image and I want to push it to the Docker Hub. So you need to rename, or you need to do a tag over here, because the same if you run docker push custom image version 1. So if you do that, it will not be pushed into this particular Docker Hub. So it's going to throw an error over here that the access is denied. So all you need to do is that you need to do a tag here. So you have to rename it in such a way that you should be able to add your username over there, because Docker Hub will identify that if it's there with your username, then only it will be pushed. Otherwise it will be simply rejected over there. So that's what you need to do. You need to rename your Docker image, the same Docker image which you have to append your username of the Docker Hub. And once that is done, so all you need to do is that you need to just run like docker, then push is there, then this image name, and then version 1. So the moment you do this, what will happen that it will start transferring those Docker image to the Docker Hub. You see this specifies that yes, this is going to the Docker Hub, docker.io, where my username is there, and this is the custom image which is available there. So if I refresh my page on the Docker Hub, I will be able to see like this public repo which is available there. But again, this one does require the credentials and the login, which we did in just last command, where we ran the Docker login command to do the login to the portal, and after that only we are able to do the setup and the modifications over here. So that's how you do the login, and you are able to connect on that. Now these are some of the pull and push operations, but let's say that if you got a container which is up and running, like this is right now we are not getting any container which is available over here. So you can say like docker run -d HTTPD, like I'm just running a dummy container over here so that I will be able to show you this command. Now if you for some reason want to go inside the container and want to see some processing and want to see some content, so you can run the command called docker exec -it, and there you can give the container ID. This is nothing but the full format of the container ID which is given to you, so you can use this one also, or you can use the shortened value also you can use. And in the last we can say like bash. The moment you do this, you will be going inside the container. You see that this is the host name which is being shown as the container ID. You can do a like ps-ef command, and it will throw an error that the ps command is not available because you are running this command into the Docker container. So using these kind of commands which is not available in container will help you to identify that yes, you are not on the host machine, you are in fact into the Docker container. So that's the reason why you can do it, because for you the paths and all everything is same, the terminal is also same, so you may not be able to differentiate in that part. So that's the reason why it's preferred that we use that commands which is going to fail, but that's okay. It will give you that okay, this command is failing because I'm into the Docker container right now. So that's what we are performing over here, right? And you can come out of that, but still the Docker container is going to be still up and running over here in this case. So the container is not going to be down over here in this one. So that's how we manage the container. We can go inside and we can check some informations and get some files there. So these are some of the commands where we can interact. Now in order to log into the Docker Hub, because before doing the Docker push you have to log in, you have to get a credentials and the connectivity with Docker Hub. So you can run the Docker login command where you can see that how the execution can be done. Now using the Docker login command you can interact with the particular Docker Hub. You can set up the credentials. Once the credentials is being set up, so what you can do is that you can go ahead and say that okay, the configurations is done, and we can go ahead and we can perform the execution. So docker login is the command where you can give the credentials. Docker info is the command using which you can get the information about the Docker tool. So whatever the Docker info is available there, so those things you can actually get it over here in the case of the Docker info. So Docker info is going to give you complete information that what exactly you have the information available over here on this one. And then we have the Docker history. So using the Docker history, you can see history of the Docker image, that what exactly the mechanisms or what are the different image IDs are available there. So this is basically giving you the complete history on how the Docker image is prepared. All the commands is available there, and that will help you to eventually go and understand that how the images can be going on, and you can manage on that part. So these are some of the couple of options which is available there, where we can see that how the executions can be done, and we can go ahead on that particular part. So Docker history is the command again which will help you to see that how you can go for the particular mechanism, and you can listen on the things over there. So Docker login was already done previously when we tried to push the image, but again if you try to run Docker login you will be able to do that. Now Docker info is something which will give some additional information about the Docker, and all the informations about the Docker will be given back to you over here in this one, so the complete clarity. Then let's say that you got a Docker image called HTTPD. Now you want to check the history of this image, that how this image is prepared, what are the different layers which is available, how many layers are there, how much size is being modified in each and every layer. So you can see that we got a layer where we have particular changes of 7.838 MB, but pretty much the from the complete size of this HTTPD, the major portion is actually of the this one, the basic operating system which is being implemented. And then of course there are some packages which got deployed, due to which this 60 MB and 7 MB size is coming up there. So this actually gives you the complete layer wise mechanism, that what are the informations which is available, that how the modifications actually got modified and got changed over here in this one. So this is the additional help which you can get from the Docker to manage the containers here. So these are the ways where you can interact with the Docker Hub. If you really want to create a volumes for the containers, so you can go for the docker volume create command. So docker volume create command is there, using which you can create the docker volumes, and you can pretty much do that setup. So docker volume create is the command which is available there for that particular part. It will create a volume for you. Now let's see that how we can actually work with the volume. So you can run the command called docker volume ls to find out at what are the different volumes which is available there. Now if you really want to create a volume over here in this one, so you can say like docker volume create, and you can go for the volume name here. Now the moment you do that, what will happen, that a volume will be created, and you can validate it with the help of docker volume ls command, that whether the volume is being created or not over here. So this is the way that how you can manage the volumes onto the Docker host. Now let's talk about some of the docker swarm commands here. Now docker swarm commands is there to set up a particular mechanism where you can see that how you can perform a setup. You can actually go here and see that how the setup and modifications can be done. So docker swarm is there where we can see that how the execution needs to be done. So you can go for the command called docker swarm init command. This will actually go for an initialization of a docker swarm cluster, and once the docker swarm cluster is initialized, then you can pretty much go there and perform whatever the executions you want to perform. You can do that, and you can execute as such over there. So docker swarm init is the command using which you can actually see that how the execution needs to be done, and how we can perform the mechanism and the changes over here. So docker swarm init hyphen advice adr address is there, which helps you to see that how the executions can be done. Now joins, you have the docker swarm join command which is available there. Now if you go for docker swarm join command, so you can have a particular host. So docker swarm join command is there, which you can run on the node machine, and in that case what will happen, that node will be a part of the docker swarm cluster. And then if you want to leave from the swarm cluster, then you can go for docker swarm leave command, and it will be simply removed from the docker swarm cluster there. Some of the couple of commands which using which we can initialize or we can remove from the docker swarm cluster here. So docker swarm is already being initialized or is being created when the moment you do the installation of docker. So docker swarm init is the command using which you can initialize a docker container. Now once you initialize over here, so after the initialization, you got a command which you want to add it, like you want to run it onto the docker swarm cluster. It will act like a worker node, so that you will be able to deploy the containers on top of that. Also, if you want to join it as a manager, so you can also get the join token again, so it will give you the proper command. Now if you run like docker node ls, so you will be able to see like what are the different nodes which is available there. And for any reason, if you're not comfortable with that and you want to reinitialize your docker swarm cluster, so all you can do is that you can say like docker swarm leave -f, and you will be left out of the docker swarm. And now if you want to run like docker node ls, you will not be able to get that output, because it's saying that there is no particular swarm manager which is available. So you can run docker swarm init, or you can run the join command to connect to that specific node, but we have already left it, and nothing is available over here. So that's a way that how you can manage like what are the different docker swarm commands we can typically run to manage the docker swarm cluster. Now let's talk about the docker compose commands. Now docker compose commands is actually there using which we can create multiple containers. It's not only one container which we can create, go for multiple creations of the containers with the help of docker compose file. So docker compose -version is the command which we can give you the version of docker compose which is being used. So here we use a particular YAML format file which will help us to create the multiple containers. We define the services, that what are the different containers we want to create here, and then with the help of a docker-compose.yaml file, we can create, or we can have that particular docker compose file set up over here in this case. So docker-compose.yaml file is used to do the setup and the modification, so that you will be able to have
have the modifications done, and you will be able to find out a particular multiple containers gets created all together. So Docker Compose is the way that how you can do the setup. How you are going to run the Docker Compose file? So in that case, you're going to run the docker-compose up command, which will help you to set up like how the compose can be done. And once you are done with the docker-compose up command, so using this, the compose will be done and the containers will be up and running. So these are the commands using which we can manage multiple containers using the Docker Compose one.
So let's try to run some commands related to Docker Compose. So docker-compose version will let you know that what exactly version of Docker Compose is installed into your system. So you can run typical apt command to do the installation. So docker-compose is the package name which you can install so that the executables and the package can be installed into your system onto the server. Now all we need to do is that we need to create a Docker Compose file. So what we need to do is that we need to create a docker-compose.yml file is the default name of the YAML file which we want to create here. That's a standard name. So once you create this, all you need to do is like you need to put some values, attributes. The very first one is the version value, that what version of this particular attribute you want to create here. Let's say that I want to create a version 2. So I will configure here that yes, the version 2 is what I require. I want to set up over here in this one. Now again, if I want to configure that what are the different services we want to run, because services is the main thing which we will be running on this machine, on this server here. So that's what we require. So then we need to put for a particular service called web. So web service we want to search and we want to run. And then again, we need to take care about the spacing because that's a very important part. And we need to provide the values of the image and all these configurations here, so that you should be able to set up like how the images and how the Docker images can be built up over here. So web is the service which we want to deploy, and then of course the image is the attribute which is there for the web, that yes, Nginx is the one which we are trying to build up. Now you can give the ports configuration also, so you can say like ports, and inside that you can say like what port mapping you want to perform. So you can say like 8080. So, or sorry, 80 is what you can dash for the Nginx because it runs on 80 port. But now I have to run like 80 port. I want to dash that port over here in this one. So I can specify that 80 port should be available in this one. So I'm going to save this one here and I'm going to run a command called docker-compose up. Now this will run the containers in the interactive mode, but if you feel that I want to run in the detached mode, so you can say like -d also, which will of course run these ones into the detached mode and it will be executed. So it will process your Docker Compose file, and since you have used a standard name called docker-compose.yml, so it will automatically pick that Docker details and start creating the container. So that's it for this particular one, in which we talked about that how exactly we can work on all these different Docker commands and how we can make use of these couple of commands there. So that's it for this one. Thanks everyone.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.